Now it's time to explore a little bit about what happens when we do deal with a negative. So let's take, for example, if I were to have the square root of negative 25. What number times itself produces a negative 25? Well, let's see, it's got to be a negative 5 times a negative. No, because a negative times a negative makes a positive. I can't find a number times itself that will produce a negative number in the set of our real numbers. So what that's going to tell us as we look at the square root function, we're going to deal with values underneath the radical that are positive or 0 or greater. So we can create a function, some f of x will equal the square root of x. And as we can create this function, let's graph a little bit of it to get a sense of what that could look like. Some values I'm going to place in there. I know that there's a point 0 and 0. If x were, let's put some marks on it. One, two, three, four. All right, some marks right there. If x were 0, my value would be 0. If x were 4, that's the next one I know for sure. The square root of 4 is 2. If x were 9, I know the square root is 3. So I have the point 0, 0. I have the point 4 and 2. I have the point 9 and 3. And I'd have the point 16 and 4 out there somewhere. And trying to draw a nice, smooth, continuous graph through those points. Imagine it being a little bit more smooth and rounded like that. That presents to us what the graph of our basic square root function looks like over a domain of 0 to positive infinity. 0, it can be a solution in this. Notice there's no values to the left of the y-axis because this is not defined over the course of real numbers for our values of x. So what do we do with that? What can we go from here? One other observation that before we continue is, what about all these other values of x that we have along the way? We have 0, 0 defined. Oh, we also know 1 and 1. Well, sorry, 1 and 1 should have been right about there. There we go. We know that the point 1 and 1 also works. Well, what about the point 2? That just becomes root 2. So we'd have the point 2 and root 2. What about the point 3? That'd be the point 3 and root 3. 4 we knew to be 2. 5 and root 5. There's a lot of other values of x's that we don't have what we call a rational number. These are irrational, meaning that we can't write them as a ratio of integers. So how do we solve that? Well, how do we know what the value of root 3 is? Well, that's where you can consult your watch, your smartphone, your calculator, whatever it might be, and compute an approximation for root 2 or root 3 or root 5.